Starting with the basic concept, this will be the lens. You call it convex lens. Usually its focal length is positive, having the principal axis, having the optical center, and this is called double convex lens because the two surfaces are there. Similarly, when you have this is called concave lens. Focal length is negative. Two curved surfaces looks like this one. For both of these lenses, the formula is the same. 1 by f equals to 1 by v minus 1 by u, and this is called lens formula. It simply relates focal length with position of object and position of image. All the distances in the direction of incidence of light is considered opposite to the incidence of light is considered as negative. So these two sides will be negative, and all the distances on the side is considered to be positive in both the lenses, irrespective of whether you have a convex or a concave lens. But be careful, all the distances इस तरफ जो भी होगी they are considered to be negative, और इस तरफ की directions जो होगी they are considered to be positive. So this is the first concept about this. Today the main concept which we are discussing is basically lens and the related concepts. Next concept is if I take the convex lens, of focal length f, if I cut it from the middle this way, f remain constant. However, intensity of light will reduce to half of the initial. So f will be remain constant if you will be cutting it like this. When you will cut it like this, then focal length become 2 times. Be careful, half nahi hoti hai, 2 times. However, intensity will remain as it is. So two changes are there. If you will cut it either from this axis or from this axis, you can see the two differences looks like this. Focal length will remain constant in first, but focal length will change in the second one. And it becomes double. Number 3. Whenever two lenses are kept in close contact, no gap is there between them. You want to find out what is its equivalent focal length. The equivalent focal length looks like 1 upon f1 plus 1 upon f2. The reciprocal of focal length is also called power. So power wise you can write it should be P1 plus P2. But if there is small distance between them, there is slight change in the formula. Should be F1, 1 upon F1, 1 upon F2 minus D upon F1, F2. When D is 0, automatically it becomes the same formula. Power relation can also be written like this only. P1, P2 minus D times P1, P2. Power is ability of a lens to convert ray of light towards principal axis. When F in meter, then power can be written as 1 upon F. But if F in centimeter, we usually take power in this manner. And the unit of power is diopter. Like when I say that if power of lens is 5 diopter, find focal length, then focal length becomes 100 upon 5. If you want it in centimeter, this becomes 20 centimeter. Or if you want it in meter, directly आप 1 upon 5 करके 0.2 मीटर लिख सकते हैं. So this is clear from this that when to use 100 upon F and when to use directly F. But power, the standard unit of power is diopter. In the same combination of lens, if I take a typical example like this, on the principal axis I am having more than one lens. Say one will be convex and other will be concave. A ray of light is starting from somewhere here. Due to its focal length, it tends to converge but meanwhile another lens is there, so due to this it will go like this, parallel to this. So this kind of thing is going on. Then for this lens L1 and this lens L2, it should be noted that for L2, I1 will act as object और क्योंकि ये डिस्टेंस इस तरफ ली है, so it will be positive. For L1 this is image, for L2 this will be object और ये जो distance है, this distance is considered to be U for your second lens. इसे इस एग्जांपल में आप विजुलाइज कर सकते हैं. When I have the principal axis having three lenses, लेंस 1 इसके और ऑब्जेक्ट के बीच का डिस्टेंस है 30 सेंटीमीटर और इसकी फोकल लेंथ हमें दी हुई है +10 सेंटीमीटर. इससे 5 सेंटीमीटर के डिस्टेंस पर वी हैव अनदर लेंस. Its focal length is given as -10 centimeter. और उसके बाद इससे 10 सेंटीमीटर पे we have given another lens. Focal length is +30 centimeters. So you have the three different focal length looks like this. अब जब आप फर्स्ट लेंस को विजुलाइज करते हैं, लेंस L1, L2 and L3. So now for L1 आप देख सकते हैं U is -30 because it is on this side. F1 is +10. 1 by F is equal to 1 by V minus 1 by U. So if I calculate, putting this, the value of V is coming out to be 15 centimeter. This is the first result. This will be for length, this one, L1. इसका मतलब अगर मैं इसको ट्रेस करता तो ये 5 और ये 10, इसका मतलब इसको आना तो यहां पर कहीं पर था, लेकिन हमने बीच में ही यहां पर लगा दिया दूसरा लेंस। अब आप देख सकते हैं इस लेंस के और इसकी इमेज जो फाइनली आई है, उन दोनों के बीच का डिस्टेंस है 10 सेंटीमीटर। सो फॉर L2 ऑब्जेक्ट प्लस 10 सेंटीमीटर, क्यों प्लस, इस तरफ है इसलिए, F गिवन है -10 सेंटीमीटर। यूज करते हैं 1/f 1/v -1/u। जब आप वैल्यू रखते हैं तो अब v आ जाता है हमारे पास में इंफिनिटी। इसका मतलब ये रे यहां से चलने के बाद, यहां से बैंड होने के बाद इस तरह से चली इंफिनिटी। जब हमारे पास में इमेज बनती है, इसका मतलब वो पैरेलल होता है इसके साथ में। सो इट्स गोइंग लाइक दिस। Now for third lens, U is infinity, F is plus 30, and V you want to find out. 1/f is equal to 1/v minus 1/u. 1/30 is equal to 1/v minus 1/infinity. 1 upon infinity is always 0. So V is coming out to be 30 centimeter. Now this is very important question. पहले पार्ट के अंदर आपको देखना है, फिर दूसरे पार्ट को आपको विजुअलाइज करना है इसी तरह से, उसके बाद में तीसरे कैलकुलेशन करनी है। The image of first will act as object for second. The image of second will act as object for third. ये देखिए, ये इसकी इमेज, ये ऑब्जेक्ट बन गई इसके लिए, and it goes like this. This is how the combination of cells can be equated. But in general, when you have two lenses, one is say convex, another is concave, this will be say plus 10 centimeter focal length, and this will be say minus 20 centimeter. ऐसी सिचुएशन के अंदर जब भी आप इनको इक्वेट करना चाहोगे, one by f is 1/10. Please put with the sign also. So it must be equals to 20 centimeter. दो कॉन्वेक्स लेंस ही साथ में रख दिया आपने। पहला है +5 डायोप्टर, दूसरा है +10 डायोप्टर। इसका आसान तरीका है, सबसे पहले पावर निकाल दे। पावर इज P1 + P2, that is 5 + 10, so I can say 15 centimeter. 15 is power. Focal length is 100 upon power, that should be equals to 100 upon 15 सेंटीमीटर के अंदर हमारे पास में इस तरह से आ जाएगा ये। पहले पावर को ऐड कर दो, प्लस प्लस है तो प्लस किया, कुछ माइनस वगैरह होता तो उसको ऐसे इक्वेट करके वी कैन पुट इट लाइक दिस। And as you know, as I have already discussed, if focal length of this will be 20 centimeter plus, then focal length of this, if it will cut straight from this one, if this is 20 centimeter, then this must be, याद रखना, 40 centimeter, बार बार बता रहा हूं, डबल हो जाता है focal length बीच में से अगर इसको कट कर दिया तो। So whenever you will take 1 upon f is 1 upon v minus 1 upon u, which we call as Lenz's formula. But when you write like this, mu minus 1, this is known as Lenz-Macker's formula. And when you equate these two, I can also write 1 upon v minus 1 upon u is equal to mu minus 1 upon r1 minus 1 upon r2. So this is the third case. 1 upon v minus 1 upon u is mu minus 1 upon r1 minus 1 upon r2. This formula can further be modified. First, for equiconvex. Equiconvex में if R1 is positive R, R2 becomes negative R, and that's why the formula will reduce to mu minus 1 upon R minus 1 upon R. This becomes 2 upon R. And when I will take plano-convex में अगर R1 आपके पास में प्लस R को शो कर रहा है तो R2 इंफिनिटी को शो करेगा, और फॉर्मूला विल रिड्यूस लाइक दिस mu minus 1 upon R minus 1 upon infinity, so that will be mu minus 1 upon R only. So this is the difference. The 6 formulas: Lenz formula, Lenz-Macker for equiconvex, and for plano-convex. 5 formulas are there. So when you write Lenz-Macker formula like this, 1 upon f is mu minus 1 upon r1 minus 1 upon r2, जैसा मैंने कल भी आपसे डिस्कस किया था, this mu must be equals to mu 2 upon mu 1 when you are moving from medium 1 to medium 2, and the formula must be mu 1 upon mu 2 if you will be moving from m1 to m2, m2 to m1. So for m1 to m2, अब ध्यान से लिखिएगा, 1 upon f मैंने लिखा है इसको mu 2 upon mu 1 minus 1 upon r1 minus 1 upon r2. If mu 2 is greater than mu 1, then f is always positive. और अगर f पॉजिटिव आ गया इस सेंस के अंदर तो हम कहेंगे this must be convex. So it will act like a converging lens. लेकिन if mu 2 is less than mu 1 और अगर f आ जाए negative, then we call it concave or the diverging lens. तो सीधा सीधा सा चेक करने का तरीका है, mu 2 अगर mu 1 से ज्यादा है तो हमारे पास में convex lens आ जाएगा, और mu 2 अगर mu 1 से कम है तो हमारे पास में concave या diverging lens आ जाएगा. So this is condition for converging lens and this is condition for diverging lens. The two different lenses looks like this.